I want to build a colour name badge display based on the Raspberry Pi Pico, and instead of using a specific module, I'm using the generic MSP2401, a 2.4-inch display. I've previously showed how to write some code to drive this, but the display itself was on a breadboard and I can't wear a breadboard, so I need to move to a PCB, like this one. Hi, I'm John, your concierge to the world of the Raspberry Pi Pico, IoT, robotics and other fun tech. Please remember to subscribe and join my community. This is my 3-minute summary on how I designed the PCB for this TFT display with the Raspberry Pi Pico. If you have time, why not watch the full video? I'm not an expert on PCB design. I only got into this part of making about 4 years ago, and I design a PCB every month or so. I collaborate with a few experts in this field and also have the support of a partner, PCB, who fabricated this board for this project. I've previously shown how to drive the display, the MSP2401, using the ILI 9431 driver from C++ on the Pico. The display was on a breadboard, and in this video I'm going to talk about the design of the PCB and my considerations in doing so, plus the assembly of the finished display. I normally start that design process from a point of view of connectivity and the circuit and schematics. This time though, the physical layout of the board was most important. The display, Raspberry Pi Pico and an LED. I found I had a little bit of space left over for a TPM module too. The schematic in KiCad shows I'm connecting both SPI channels to the TFT display. One will drive the display and the second will drive an SD card. These boards have an SD card adapter on board. The SD card SPI0 will also be used by the TPM. I'm using the pins on the left hand side of the Pico generally for these modules. Once I've got a schematic, I lay the design out for the PCB in KiCad. Most important thing was the positioning of the connectors and the bolt holes for the display. This took some measurement as I'm using 2 female header pin connectors to represent the module. To make the routing easy, I decided to use a 4-layer PCB. This is my first 4-layer PCB board, and I've not necessarily followed the best approach to routing. The board works though, and KiCad design rule checks pass, well apart from some warnings around signal screening that I'm not too concerned about. PCBs are so much easier to solder up than prototype board, so this was very easy to put together. I added some 3D printed backing containing the encapsulated magnets for attachment, and for power I'm using a LiPo battery through a LiPo shim module on the bottom of the Pico-W, shown here. I'm really pleased with the outcome of the project. PCB did an amazing job with the PCB. It looks good, and with their help I got the board nailed first time. If this video or any of my videos helped you out, why not buy me a virtual cup of coffee or lunch to say thank you? There's now that super thanks feature live on the channel. Just click the button. Thank you very much for watching. If you enjoyed the video, please hit the like button and please subscribe to my channel so you don't miss the next video. Bye bye for now.